Okay, stats, this is day 5. We are on chapter 6. Just this page here. There's quite a few questions on it though, and it might take you just a touch of time to do. We're going to go through this top part here and kind of talk through some examples and stuff, but things that you will need for this page are, let's see, where did I put it? Right here. Your positive and negative z-score table. He is a laminated sheet. Yours does not look like mine because I just screenshotted these and put these on here. But it should be one full page, front and back. This is the same paper, laminated. Okay, positive z-scores on one side, negative z-scores on the other. Okay, all right, so we're going to use that. Make sure you have him so you can look these up as we go through. Okay, so here we go. Let's talk through empirical rule for just a second. I think we used this just a little bit ago, like the other day. We did some questions with the empirical rule. So let's say that, I don't know, let's say the average score on a test, I think I did this the other day, was an 85, okay, with a standard deviation of 5, okay? So that means that 85 goes here in the middle, okay? That's the average score. 50% of people are scoring above that, 50% of people are scoring below that. That's what it means to be average, okay? If you add the standard deviation, I made it really easy. This is 5, so we have 90, 95, 100, right? Okay, and then we have, if we subtract 80, 75, and 70, okay? Now, if you are looking at the numbers, those numbers exactly, like if you're looking at, hey, I got a 90 on my test, like what percent of people scored above a 90? This many percent of people, I think if you add those all together, it's like 16%, okay? This many people, all of these added together, scored below a 90, right? Like that's how the empirical rule works. Okay, somebody came up with this after they crunched a bunch of numbers and said that if it's evenly distributed, this is how the numbers crunch down. I can find out that about 34% of people should have scored between an 80 and an 85. Like that's how that breaks down. But the problem is, what happens if you're talking about like a data value like a 91 in here, right? That's like not on an exact whatever, like a 91, where does he live, right? So a 91, if we're talking about z-score, which is what most of this is about, we're talking about z-scores here, and we dealt with this formula the other day. To calculate z-score, you have my value, which is x, and then x bar is the average, and then the standard deviation is this bottom guy, right? Okay, so you take my value minus the average divided by the standard deviation. That'll pop out your z-score. Okay, your z-score corresponds to where you're at standard deviation wise. So if you are on an 85, your z-score will be 0. You are like at the 0 station. If you are on a 90, you are at the 1 station. Your z-score will be 1. These are all z-scores. 95 will be a z-score of 2. 100 will be a z-score of 3 exactly, right? Then this will be a z-score of -1 if you're at an 80. -2 will have a z-score of 75. -3 is the z-score for 70, right? So if I'm at like, let's say a 91 right here, okay? 91 is going to be a decimal number between 1 and 2, right? 91, okay? If I take 91 and I subtract, 91 is my value, and I subtract the average, which is 85, and divide by the standard deviation, which is 5. 91 minus 85 is 6/5, which is 1.2, I think, ish. My z-score would be 1.2, okay? Now, using that information, if you are at a decimal point, you can't use the empirical rule to figure out what percentage are below you and above you, right? That's where we have to figure out this z-score table right here, okay? These z-scores, positive z-scores, negative z-scores. So if I'm going to draw my bell curve here. Here's where 0 was. If I was at a 1.2 for a z-score, what percent of people would be below me and what percent of people would be above me? I go to the positive z-scores because 1.2 is positive, right? It's on the right side of 0, okay? 1.2 z-score right here. I'm looking at these, okay? 1.2, and I go over to 0 because it's just 1.20, and it is this guy, 0.8. I can't see that very well. 0.8849. 0.8849. That means 88% are below me, and and the other one is above me. Now, the way that these work, I don't know if you remember from when we did this in this section, but if you look at this table right here, every time you're looking up a percentage, you're looking from everybody that's to the left of you. So if they ask you for what percent is to the right of you, you're going to have to subtract that. 0.8849, if I subtract, is 0.1151, something like that, right? So 11% or almost 12% are above me and 88% are below me, right? That's how that works. So when you are on a decimal z-score, 1.2, okay, not like an exact one, right? If I'm exactly at 1 and exactly at 2 and exactly at 3, I can just use the z-score table and it makes it really nice. But or the empirical rule table. But if I'm not and I'm at a decimal, I have to use the other table, right? So here, if I had a z-score of 1.27, this is just an example. Like 1.27 has nothing to do with the example that we just did. This is just showing you. Z-score of 1.27, if you look it up on the chart, means that 89.8% are below you, and then you can use that to calculate how many people are above you, okay? So there's how that works. All right, for your information down below, you are using average age for students in our class, okay? That is going to go with, let me go up here, average age, going to go with exact age on graduation day. That's what you're looking for. Okay, so this is the column that you're going to use. Okay, now we've already calculated average, right? The average age, I will go ahead and let you use 1 decimal place if you want to. Yeah, 1 decimal place. Yeah, sure. We'll do 1 decimal place. So the average age is 18.4 years old. And the standard deviation, if I round to 1 decimal place, is 0.5 years, okay? So half of a year, and 18.4 is the average, okay? So going down here, fill that in, 18.4 and 0.5 years old. Okay, use that to fill out your bell curve. 18.4 goes here, then add 0.5, add 0.5, add 0.5, subtract 0.5, subtract 0.5, subtract 0.5. Okay, what is the z-score for your age? So you're going to take your value and do the formula to it. Okay, now again, that's your age, so you should not, unless you are Marcus and Gracie, you guys will have exactly the same answer for 32, but nobody else should have the same answer for number 32. 33, what percent of students are younger than you? What percent of students are older than you? Okay, what percent of students are younger than 18.5 years? So here, you're going to have to calculate a new z-score and figure out what percentage that is. 19 years, you're going to have to calculate a new z-score. Then they ask for what percent of students are between 18 and 19 years old. Okay, so let's mark that out. If 18.4 years old is the average, and they want to know what's between 18 and 19, okay, I'm going to calculate the z-score. This z-score is going to be a negative number. This z-score is going to be a positive number. If I look it up on the chart, it will tell me from here back. If I look this one up on a chart, it'll tell me from here back. If I want to know who's in between those, I subtract those 2 percentages. After I calculate the percent from the table, right? I look the percentage up on the table, and I can figure out what percent is between those two, okay? All right, let's do one of these. How old is a student who has a z-score of 2.25? Okay, 2.25 means they're much, much, much older than 18.4 years old, okay? But how old? Okay, so these 3 are going to be calculated this way. How old is a student who has a z-score of 2.25? I know to calculate z, you do x minus x bar, and you divide by the standard deviation. If we're using 18.4 as the average, 0.5 as the standard deviation, I want to know they have a z-score of 2.25. I'm trying to solve for x, right? So all I need to do is unwind this equation here, and I'm going to multiply by 0.5, so times 0.5, and then I'm going to add over 18.4 to undo that. So add over 18.4. Let me get an answer for you. Hold on a sec. I have 2.25 times 0.5, and then I'm going to add to that 18.4. We know it's got to be older than 18.4, right? Quite a bit older. They are 19.525 years old. Okay, so 19 and a half years old, almost, 19 years and 6 months about. So that is how old a student is, 19.525. is what you're going to go with, okay? How old is a student that has a z-score of -3? That's going to be much, much, much younger than 18 and a half years old, like maybe 17 years old, okay? All right, and then these next three here, I'm going to do number 42 with you. So 42 is asking for the 85th percentile. Okay, if you are in the 85th percentile, that means your age separates the top 15% from the bottom 85%. 85th percentile means 85% of people are below you. So if here is average, if here's where 0 lives, right, and you are in the 85th percentile, you are taller than, or you are older than 85% of people, which means you're going to live over here somewhere, and 85% are below you. So we got to figure out what that number is right there, okay? All right, 85%. We're going to look this up backwards on the chart, okay? And 85% is 0.8500, okay, because we need 4 decimal places. So what I'm going to do is I'm going to go down to my positive chart, and I'm going to look this up. These are going to be the backwards problems. Backward on the chart. So I'm looking up the number in here that's closest to 0.8500. Okay, and they go in order. So like here's at 87%, here's at 8508. Okay, so right here, 80.8500 is going to be somewhere in between those two. Which one is it closer to? Is it closer to 8485 or 8508? 8508 is probably going to be the closest. Okay, let me zoom in. 8508 is closest to 85th percentile. So I need to figure out, if I go over, that is 1.04. Okay, 1.04 is the z-score for that. Okay, so I know that the z value is 1.04. Now, find the age. I don't want the z-score, I want the age of that student. So if z equals x minus x bar over s, I know the z is 1.04, and I'm finding x, just like we did in the last problem. X bar is 18.4, and 0.5 goes here. I'm going to multiply by 0.5 times 0.5, and then I'm going to add the 18.4 over. Okay. Let's see what I get. 0.5 times 1.04, and I'm going to add 18.4, and I get 18.92-ish. So almost 19 years old. Okay, if you are in the 85th percentile, meaning that you are older than 85% of all of the seniors in your class, you're going to be 18.92 years old or older if you're in the 85th percentile, okay? So fill in the rest of those holes. Some of them take a little bit of time, but there you go. That's all I have.